Assalamualaikum and good day guys. In this video we're going to proceed with the next topic in EQT101, which is differentiation and integration. Alright, of course, as the name of the topics, we're going to start with differentiation and then we'll go to integration. Right, so let us be clear in what is actually a differentiation. When we're discussing on differentiation, what does it actually do? Alright, I believe that most of you guys are already familiar with the terms used in differentiation, which is dy dx. Right, this is the terms used in conducting differentiation, and this notation is not just being randomly created. Right, this has its purpose. Dy over dx, right, it is actually portray the process of differentiation, or we can say that the process of finding a derivative. Okay, later we'll show you what does it really happen when we conduct differentiation. What is actually what they actually look at when they conduct differentiation. Right, this is actually the difference in y over the difference in x. Right, the idea of differentiation is actually they want to find a slope of a function of a graph. And we have several kind of graph. We have a quadratic, a cubic, with different shapes. And by looking at the differentiation of that equation, an equation of maybe a quadratic, let's say, right, we are just simply looking and to create an equation in finding a slope. Okay, let's look at this explanation. Alright, you can look, if you want to look by your own, you can look at this side. So what does it really happen when we conduct differentiation? Okay, when we want to look for derivative using differentiation, what we are looking at is actually a slope. We're just looking at a slope. That is the main idea. So the way to look at the slope, right? For example, we have this part of the graph, right? We want to look at the slope, right? If it is a straight line, it is simple. You just find out the change in y divided to the change in x, so you'll get a slope. Okay, the gradient. However, if it is not a straight line, okay, first we can find the average slope between 2 points. For example, like this. You have this point which have a difference of 15. So x for this point with x at this point, their difference are 15, and y at this point with y at this point, the difference is 24. So it is basically the average slope for this line is 24 over 15. But that is not really accurate because it is not a straight line. Right? So to find the exact slope, we'll need to go, we need to zoom in. So when you zoom in, it will, of course, be too, we can say micro, right? So the difference will approach 0. So to just use this formula, it will be nothing to measure, right? So if you try to zoom in up, you'll see that even though it is close to 0, it is actually still a value. Right? If you try to zoom in, there is still a value. Instead of try to each time we try to find out the value and divide using this formula, we can create, right? We can create another formula, right, of derivative, which based on this, based on the basic idea of the difference in y over the difference in x. Okay, so I'm not going to explain the formula here. This is the formula that being created based on this idea. Okay, and by right, this formula can be used in any function that you encounter in mathematics in finding the derivative. However, to use this formula in all kind of situation, let's say you have a function with power, you have a function with a quotient, or maybe reciprocal, so you might face difficulties, or maybe you have a function that is actually mixed with several other functions. So to just use this will be a little bit complex. If let's say you just want to solve for x squared, yes, you can use this to get later 2x as the result of the derivative, right? Or you can also use a simple question like x cubed, x to the cube. So you can solve it using this formula. However, in order for us to be able to conduct derivative in certain different situations, right, mathematician has created a kind of rule of thumb or kind of preset formula that can be used, so that when you encounter with certain situation, you can just use that formula to conduct a derivative, right? But the basic idea is that when you conduct a differentiation, you are actually finding a slope. Okay, you are finding a slope. Okay, this is what really happened. For let's say this is x squared, this is the graph of x squared. When you are finding a derivative, you actually finding a slope. Okay, this is what really happened. You are finding the slope of a straight line. Later you are going to learn about tangent line. So this is a tangent line. So this is what we are looking at later. You might want to look at the slope where x equal to 0, or maybe at this point x equal to 1 So the slope is around 45 degrees, right? It has a value there. Okay, so this is what we are looking at in differentiation. Okay, so there's in our syllabus there's around 7 basic derivative function that we can use later. Okay, so we have derivative of power function when you meet with a function with power, right? We have derivative of constant times a function when you have a function that times with a constant. How we are going to conduct a differentiation. And then we want to find a derivative for the summation and difference between function. We also have a derivative of a product using product rule when we want to multiply, right, between function. And then we also have derivative of a quotient rule. So this involves division. And of course, we have a derivative of trigonometric function. When you encounter with a function that involves trigonometry, right? Sine, cos, tan, how we're going to deal with it. And then we have also derivative of exponential and logarithmic function. We are going to talk more about this, right, in the next video. Okay. We also have a chain rule where we have several functions mix up together. Right? Those are the kind of preset derivative, preset differentiation function, preset derivative that we can use, right? Rather than we just use the actual formula, because to use the actual formula it will be a little bit complex when you encounter with different kind of function. Okay, so we're going to talk more about that in the next video. Thank you.